Unit 12, Dimensional Change, Lesson Part 2. Remember at the end of the previous lesson, we talked about the scale factor and how the exponent matches the unit's exponent. So if you're given a perimeter and asked to find the new perimeter and nothing else from that figure, you would take the scale factor that they mentioned in the problem times the old perimeter to find the new perimeter. Same thing for area. If they only give you the original area and want to know what the new area is going to be, and they say, for example, that they tripled all the dimensions, you would take 3, which is the scale factor, raise it to the power of 2, which would be 3 times 3, or 9, and take 9 times the original area to find the new area. So if they only give you the original and a scale factor, it's possible to find um, the new areas, volume, perimeter, or whatever is asked for without actually going through the entire figure and changing all the dimensions using these rules right here. So we're about to practice this right now. The volume of a pentagonal prism is 1792 cubic inches. Its surface area is 608 inches. If the dimensions are divided by 4 to create a new prism, what would be the surface area and the volume of the new prism? So they didn't give me the dimensions. The only thing they mentioned is that the dimensions are all divided by 4. So in this particular problem, our scale factor is 4. So again, the original surface area is 608 inches squared. And our original volume is 1792 inches cubed. So if I want to know what the new area would be, I take the scale factor to the power of 2, because area is always to the power of 2, and that gives me 16. And I'm going to take that value and multiply it with the original area, 608, to find my new area. Same idea with the volume. I take the scale factor, again 4, but this time I'm going to cube it, and that is actually 64. And I'm going to take that times the original volume to find the new volume. So let's grab our calculator and do these calculations. Okay, so first one is 16 times 608. Oh, I'm so sorry. Rewind. It's divided by 4, which is the same thing as 1 over 4. I need to fix that. Oh, these pop-ups, my goodness. So, sorry, wrong scale factor. We're dividing by 4. which means the figure's going to get smaller, not larger. So the scale factor should be 1 over 4. So I'm going to take 1 over 4 and square that, and I would get 1 over 16. And I'm going to multiply 1 over 16 with 108. I'm sorry, 608. Same thing for the volume. It's 1 over 4, but this time I'm cubing it. So it's ended up being 1 over 64. Now let's put it in the calculator. So you can do alpha y equals 1 for the fraction, or just simply put it in parentheses. So 1 over 16 for the first one. If you put it in parentheses, you have to do it exactly like I've done. And then multiply it times the original, so 608. That's much better. It's supposed to get smaller. Whenever you're dividing your dimensions, you're making your dimensions smaller, so your figure should be smaller. And let's do the volume while we're at it. So the new surface area is 38 inches squared. For the volume, it's 1 over 64 times the original volume, 1792. So the new volume would be 28. So surface area is 38, volume is 28. So 38 inches squared, 28 inches cubed. These are the new prism values. So that rule is very handy that we mentioned on the previous slide. So again, remember these, and it could save you a lot of time in your future. Now, this is only true, that slide where I gave you all those rules, if the scale factor for each dimension is the same. And when it is the same, we would say that the figures are similar figures. So if the scale factor for every dimension is the same, we say the figures are similar, meaning they're proportional. However, it's not similar if one dimension has one change and the other dimension has something different. So let's practice this. So the base of a rectangle is multiplied by 4 and the height is multiplied by 7. Describe the effect of each change on the area. So we get to make up our own example on this one. So let's draw a rectangle. Okay, and let's keep it simple as possible. Say our original base is 2 and no, that seems small. Let's say 4. And our height is 2. So let's find the area of this original. Again, it's base times height. So that means it's 4 times 2, which is 8 units squared. So now it says our base is multiplied by 4. So 4 times 4 is 16. And then our height is multiplied by 7. So 2 times 7 is 14. Find the new area. So let's find the new area. Again, it's base times height. So it's 16 times 14. And let's grab our calculator to calculate this. 224. So 224 units squared. So let's see how much of an effect that was by finding our ratio. So our ratio, or our scale factor, was different for each dimension. So the base was multiplied by 4, the height was multiplied by 7. So if I found the ratio of new to old, it's 224 to 8. Let's see if this can reduce. It reduces to 28 over 1. So the new area is 28 times larger. So the new area is 28 times larger than the original. Um, I'm wondering if it'll work like that all the time. 4 times 7 is 28. So I wonder if that has something to do with it. That might be something to look into in your future. So let's practice some more and see if they are similar or not. So the first one is talking about a triangle. And we need some dimensions. So again, I'm going to keep it as simple as I can. So let's say 2 and 3 are my original dimensions. Let's find the original area. Again, area is base times height over 2. So that would be 3 times 2 over 2, which is 3. That's my original. Now it says it wants us to multiply our base by 2, so this becomes 6, and our height by 6, this becomes 12. So let's find the area of the new. So that would be 6 times 12 over 2, which is essentially 6 times 6, so that's 36. So the ratio is 36 to 3, which is 12 to 1. Are these similar? No. Again, in order to be similar, the dimensions have to be multiplied by the same factor. However, look at that. The ratio is, again, is 12 to 1. And when you look at how we manipulated our dimensions, 2 and 6, it multiplied together, and the new triangle area is 12 times as large. So the area of the new is 12 times larger. So far, my theory appears to be working, that these two scale factors multiplied together will explain how the new area will change. Very interesting. I want you to do the number 4 on your own. Let's talk about number 12. We have a rectangular prism. I'm not going to draw the prism. However, to find the surface area of this prism, surface area is equal to perimeter times height plus 2 bases. So let's say 4 and 5 are use to find the perimeter. So it'd be 2 times 4, which is 8, plus 2 times 5, which is 10. So 8 plus 10 is 18. That's my perimeter. And it tells us the height is, oh, I'm sorry, these aren't actual numbers. Rewind. Erase, erase, erase. Okay. Let's say my original dimensions are 2 by 3 by 4. All right, we're going to keep it simple. So let's say 2 and 3 represent the length and the width of my base. So it'd be 2 times 2, which is 4, plus 2 times 3, which is 6. So 4 plus 6, my perimeter is 10. You might need to draw this out if you really need a visual or just understand what I said. So the height of my prism, the distance between my bases, is 4. Plus 2 times the area of my base. So 2 and 3 are the dimensions of my base. So that'd be 2 times 3, which is 6. So my surface area is 40 plus 12, which is 52. Now for the volume. Volume is easier. For a prism, the volume is going to be length times width times height. So that's 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. So that's the original volume. Now we need to calculate the new surface area and volume. So the length is multiplied by 4. So 2 times 4 would be 8. I need more space on this one. And my width is changed by 5. So 3 times 5 is 15. And then my height is changed by 3. So 4 times 3 is 12. So these are the new dimensions of my rectangular prism. Again, you're going to need space because now I need to take these measurements and find the surface area. So the surface area, again, it's pH plus 2b. So to find the perimeter, I would take 2 times 8, 16, plus 2 times 15, which is 30. So 16 plus 30 is going to give me 46 as my new perimeter. My new height is 12 plus 2 times b. So to find b, it's 8 times 15. 8 times 15. $120. So 2 times 120. So my new surface area is 46 times 12 plus 2 times 120. Put all that in a calculator in one step. 46 times 12 plus 2 times 120. 792. Let's go ahead and do the new volume while we're at it because that's going to be 8 times 15 times 12. It's 1440. So 792 and 1440. And the volume 8 times 15 times 12 is 1440. So, are these similar? No, they're not similar because the dimensions were not manipulated by the same scale factor. However, let's find the ratio. Let's see if my theory still works. So the ratio of surface areas would be 792 to 52. And the ratio for volume is 1440 to 24. And let's see what happens in this scenario when we reduce in our calculators. So 792 divided by 52. Ooh, that's not so nice. I wonder what this is as a fraction. 198 over 13. Okay. And 1440 for the other one over 24 is 60. So the volume is 60 to 1, but the surface area is 198 to 13. Interesting. So definitely not similar at all. So 198, 8 to 13, and this is 60 to 1. So the volume is 60 times larger. So 4 times 5 is 20. 20 times 3 is 60. So my theory, where you just take the scale factors and multiply them, it worked on the volume, but it didn't work on the surface area. So that's very interesting to note. I want you to do number 6 on your own. Make up your own radius and height. Then apply the dimensional changes and find the surface area and the volume and compare the ratios. Also, don't forget to answer the question, is the original and the new figure going to be similar? Yes or no? And this concludes our notes for today. Again, make sure you finish number 4 and 6 on your own.